Hello, guys. Today we are going to finish lesson 2, which remember was about rational numbers. And we're going to continue it today so that we not only plot rational numbers on a number line, but we are going to compare and order the rational numbers. All right, so let's get started. So, yesterday we talked about what a rational number is. Rational numbers extend the integers. Integers are positive and negative whole numbers, including 0. Rational numbers go beyond that and start including positive and negative fractions and decimals. So, we did that yesterday. Last week, we knew how to plot integers on a number line. To plot integers on a number line, you just count up your whole numbers from 0, you count back your whole numbers from 0, and you have positive and negatives. So we already learned how to do that. Now what we're doing is we're dividing the number line into fractional parts. For example, I could put tick marks in between each of these and divide all of this into halves, okay? I know on this number line that there are 2 pieces that make a whole. And then I can plot rational numbers. I can put a dot right here, and that represents -1 and a half. Okay, so I'm plotting rational numbers. That stuff we've all already done. Today, what we're going to focus on are the last 2. The last 2 are comparing and ordering rational numbers. So what's bigger, -1 and a half or a +2? And we're going to use rational numbers to represent real world quantities. So that is our goal for today. And it's going to be based a lot on what you know about your number sense from elementary school, which numbers are bigger, which numbers are smaller, and how to compare decimals. Okay, so let's go ahead and get busy. So here's a review of the number system. I've already touched on it a little bit, but I want to make sure we really know this first standard, okay? Or this first target. We want to be able to identify rational numbers, integers, and whole numbers. So whole numbers are elementary school basic numbers you start with. 0, 1, 2, 3, 4, 5. They're all just your counting numbers. This is a fraction, but it's really a whole number in disguise. 15 over 3 is 5. And then we get into integers. Integers go beyond the whole numbers. So we still have 0, 1, 2, 3, 4. But now we start having the negative versions of those numbers. This is just a whole number in disguise. It's actually a -7. Okay? And then rational numbers are the different things where you have fractions, you have decimals. Some of the decimals can repeat because remember this bar means the 6 repeats forever. So rational numbers include all your counting numbers, their opposites, but it also has the positive and negative decimals. Okay, so now that we've reviewed that, let's go ahead and start with plotting them. We're going to review the plotting we learned last class, and we're going to use the plotting to help us put them in order. So the directions on this slide said to plot each of these rational numbers on the number line. Okay, so I am going to use my color coding scale for this. So red is 1.25. Well, it's positive, so I know I need to go at 0, and then I need to go positive 1.25. But I have to figure out how my number line is divided up. What tick mark would that be? So I am going to take 1 and 2. These are 2 whole numbers that are labeled. Each of these tick marks divides my whole up. If I do this, I know that there are 4 sections in my graph. So that means I am looking at fourths. So this is actually 1 and 1/4. I know this because 25 cents is 1 out of 4 quarters. So let's go back to my graph. I know my graph is divided into fourths, and I want to go +1 and then 1/4. I want to go 1 tick mark past it. Okay, I want to go 1 tick mark past it. So that's where my red dot goes. My orange dot is -3 over 2. -3 over 2, that's weird to me. So I'm going to rewrite this. This is the same as negative 1 and a half. Okay, I know how to deal with halves. I can do this. So negative means goes backwards, but you always start at 0. So I have to go backwards 1, and then I have to go back halfway between this whole number and the next whole number. So my dot's going to go here. I'm going to go backwards 1 and then halfway. Another way to think about this is you could have changed this to a decimal and got a negative 1.5. Then you could know you're supposed to go backwards 1 and 0.5 is half. So let's look at the green. The green is negative 1.25. Well, hey, I know this is going to be a negative 1 and 1/4. Remember, we're talking about money here. So 25 cents is 1 out of 4 quarters. So I'm going to go backwards 1 and then 1 of the 4 tick marks. And then blue, positive 1.5. Well, I'm going to go forward 1. And then I have to go forward halfway between the 1 and the 2. Now, the direction said plot. I just plotted each rational number on the number line. Then it says we're going to put these in order from least to greatest. Well, remember, left is least. Okay? The numbers to the left are the least or the less, and right is the biggest. Okay? R and B, okay, they kind of look similar. So when you go to the right, you get the bigger numbers. So to put these numbers in order, orange goes first. So negative 3/2 is the smallest. The next smallest is green. So negative 1 and 1/4 goes next. I kind of wrote that weird. The next one I come across is red, which is going to be 1.25. And then the last one, the biggest, is blue, which was 1.5. So whenever you're asked to put rational numbers in order from least to greatest, what you can do is you can put them on a number line. And once you have their dots on a number line, the dots go in order from least to greatest. And then you can just write down the corresponding numbers that went with each dot. Now, I'm not going to lie, this kind of takes a while. Okay, it takes a while. You have to have a number line, you have to understand the tick marks. So there is another way to be able to put rational numbers in order that relies on the use of a calculator. Okay, so I'm going to clear this off, and you're going to need a calculator. A cell phone calculator would suffice for this. I'm going to use the Desmos calculator. The most handy calculator to have is a TI-15 because it has a fraction decimal button on it where it will convert back and forth for us. Okay, but I'm going to use Desmos since we're virtual and I know everyone has that. So our job is to convert each rational number. Well, our job's right here. Here's the directions. The directions say to put this in order from least to greatest. Okay? And instead of making a number line, it's telling me another way. I can convert, that means change, each rational number to a decimal. So I want to change all of these to decimals. Okay? So I'm going to have to kind of split my screen here. So let me erase this and split my screen so we can see my calculator and my presenting screen. All right, so I need a new tab. How do I do this? I want a new window. Do I just open up another internet? This is where I'm like, do I really understand technology? Okay, here we go. I want to go to the Desmos calculator. There is a link to it in your Canvas page, and I'll show you where that link is. I'll show it to you in just a second. I want to get this all situated. I'm going to make this smaller. Okay, too small. All right, so the link to the Desmos calculator is in Canvas. You would go to your Canvas homepage, and it has an orange link right here. Okay. And I want to bring my calculator up so that I can see both screens. Oh man alive, I am struggling. Okay, we're just going to have to make this smaller. So I want to change each of my questions or each of my rational numbers into a decimal. So this one's already a decimal. This one is already negative 0.5. It's fine, okay? Now, half. A half, I know what it is as a decimal. If you don't know what a half is as a decimal, all you have to do is come over here and you would do, I gotta make it big, sorry guys. You would do 1 over 2. Do you see this? I use this AB to make this fraction. 1 over 2. And it gives me my answer as a decimal. It's 0.5. This button changes it back to a fraction. Push it again, you go to a decimal. Fraction, decimal, fraction, decimal. So this is how you type in a fraction, AB. So this one is going to be a positive 0.5. Okay, this one's already a decimal. I can leave it. And then 3/4. I know 3 out of 4 quarters is going to be 75 cents, but I can also use my calculator. 3 over 4. It tells me it's 0.75. So 3/4 is 75. 3/4, 0.75. 3 out of 4 quarters is 75 cents. Okay. So now what I'm going to do, now that I have all of these in decimals, is I'm going to focus on my negatives. Negatives are smaller, okay? Negatives are smaller. Every negative is going to be smaller than a positive. So I have negative 0.75 and negative 0.5. So when you think about these, you want to think about the one that is furthest below 0, the one that goes backwards the most. So either I can go backwards 50 cents or I can go backwards 75 cents. I end up going backwards the most with the 75 cents. So this one is the smallest. I'm going to eliminate it. That means this one is the next smallest because it's the only other negative. Negatives will always be smaller than positives. So I'm going to eliminate that one. Now I have 0.5, which is kind of like 50 cents, and 75 cents. So which is smaller between 50 cents and 75 cents? 50 cents is. So the half comes next. Okay, I use the forms they give me originally. And that means the only one left is 3/4. 3/4 has to be the largest. And if you had put those on a number line, this is the order the dots would be in. Your first dot would be at negative 0.75. The next dot would be at negative 0.5, and then half and 3/4. So you can use a calculator to put these in order. So we are going to try another one. I'm going to erase this. And most of the decimals you can convert in your head, but if you need to, you can use a calculator. So the next one, the kids did through Pear Deck. They tried it. I'm still going to do it with you. So I need to change all of these to decimals. So I have negative 4/5. Well, let's go to my calculator. 4 over 5 is a 0.8. 4 over 5 is 0.8. So that means this is a negative 0.8. I know a half is 0.5, so this is a negative 0.5. Everything else is already decimal for me. So let's locate our negatives. Here's our negatives. These ones go first. They're going to be the smallest. So you have to think about which of these is the furthest back, the furthest from 0, the furthest negative. Well, negative 0.8 is going to be the furthest to left on the number line. So negative 4/5 is going to come first. And then out of these two, the one that's furthest back, furthest away from 0, is negative 0.5. So negative half comes next. This negative is the only negative left, so it is going to be smaller than the positive. The positive is the greatest number we have, so it goes last. And we have successfully put them in order from least to greatest. The one that is furthest to the left on the number line to the one that's furthest to the right on the number line. Let's see what else we need to try. Let me erase these. And Here's one more for you to try. So this one, I want you to actually pause the video and see if you can put it in order. I do not know why there's a line there. I tried to erase it and it wouldn't erase. So pause the video and see if you can put these in order, okay? All right, so the first thing we need to do is put them all in decimals. The first one's already in a decimal. -2.5 is -2.5. Okay, so that's what this one is. -8/3, well, I'm not sure. So I need to go to my calculator. I'm going to clear this out. I'm going to do 8/3. Okay, it gives me 2.666666. We call that 2.6 repeating. The only reason there's a 7 there is because your calculator rounded it up. So 2.6 repeating, but I believe my original one was negative. Yes. So this one is going to be -2.6 repeating. A bar over top means repeating. And then I have to go figure out 9/2. So let's go back to my calculator. So I'm going to clear it, and I'm going to do 9/2. Gives me 4.5. And I got to make sure if it's positive or negative. It's positive. So this one is 4.5. So remember, if you're going least to greatest, you start with the negatives. Negatives are always smaller than a positive. So I want to think which one of these is furthest from 0. Well, the one that's furthest from 0 is the quote-unquote bigger one. 2.6 is bigger than 2.5. So this one's furthest from 0. It's the least. So -8/3 goes first because it's the furthest to the left on a number line. -2.5 has to come next because negatives will always be smaller than positives. And then it leaves me with my two positives. You have essentially $4.50 and $4.75. You want to know which one's smaller? Well, $4.50 is smaller, so 9/2 comes next. And then the biggest is going to be 4.75. So if you got that right, big pat on the back because it's challenging. It is definitely challenging. So we did the hard part first. The next part's much easier. The next part of this lesson is just comparing integers. We don't have to put a big list in order. We're going to be given two integers, and we simply have to decide which one's bigger. So let's flash back to elementary school. In elementary school, you have that alligator mouth. We call these inequality symbols. Okay, inequality symbols. They show which one's bigger or which one's less. And you can also have two things be equal. So we're going to use those alligator mouths to show which rational number is bigger. And remember, Allie the alligator always eats the bigger number. This is going to satisfy this part right here. Compare and order rational numbers. So let's look at these two. I have 1/10 and 0.09. Well, that's very hard for me to compare right now because one's a fraction and one's a decimal. So I need my handy dandy calculator, and I want to change 1/10. So let me clear this out. I want to change 1/10, and I'm just going to do 1 divided by 10. Where's my 0? There it is. I messed it up. 1 divided by 10, and that gives me 0.1. So remember, a division sign is the same as a fraction. So 1 divided by 10 gave me 0.1. Well, let me go write that down. So I have 0.1 and I have 0.09. Well, it's hard to compare right now because they're different lengths. So let's make them both have two numbers after the decimal. So now I have a 10 compared to a 9. Which is bigger, 10 or 9? 10 is. So the alligator wants to eat the bigger number. Now let's look at these two. Oh goodness, they're both negative, okay? And I have to figure out what this is. Well, let's go use my calculator just to be safe. So it's 1 1/4. So I need to do 1/4. Whoa. See, I'm no good at my calculator either. I'm used to using the one that's like an actual handheld calculator. Get the 1 in front of it. So I have 1 1/4. You see that? 1 and 1/4, and I want to change it. I want to change it to a decimal. It didn't seem to work, did it? Oh, what can I do? What can I do? I know. It told me 1 and 1/4 is 5/4. So maybe I should do 5 divided by 4. And it's going to give me the wrong answer. Oh my goodness, what am I doing, guys? I am not used to using this calculator. Don't hit this answer button. It messes things up, okay? So you would do 5 divided by 4, and it gives you 1.25. Now, I went through all the steps of showing you how to use the calculator, and all I really did was confuse myself. I know 1 and 1/4 equals 1.25 because I have $1 and 1 out of 4 quarters. That means I have $1 and 25 cents. So sometimes the calculator doesn't help us because all it did was confuse me. So let's go over here and write. So I have negative 1.44 being compared to negative 1.25. Now, if these were both positive, I know this one would be bigger if they were both positive. But since they're both negative, it's the opposite. This one's actually bigger. The reason is because it's closer to 0. Okay, it's not as far to the left. So you can think of this as, look at the two numbers if they're both negative. Think like they're both positive, so ignore those negative signs. If this one's bigger when positive, it means it's actually smaller when negative. Everything becomes opposite when you go to negative land. We got one more to do. Negative 2/3. Let's hope Ms. Pitcock doesn't get confused with her calculator. Okay, so I want to do negative 2/3. So I'm going to do 2 divided by 3 for 2/3, and it gave me 0.6 repeating. Okay, 0.6 repeating. So I have negative 0.6 repeating, and then I have a negative 0.8. They're both negative. So if they were both positive, this one would be bigger. Therefore, in negative land, this one's bigger. It goes opposite land. So we are using alligator mouse inequality symbols to compare which rational number is bigger. So let's see if you can figure it out. Erase, 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 erase. Okay. So this is the one where you would try. So pause it, see if you can figure out what alligator mouth goes where, and then we'll check it. All right, friends, you ready? Okay, so we are going to do 0.5 and 2/4. Okay, 0.5 and 2/4. So let's get my calculator just in case, my Desmos calculator. 2/4. 2 divided by 4 is 0.5. I knew that though. So we have 0.5 and 0.5. Those are equal. Those are equal. Okay, now I'm going to use my brain this time and not a calculator. I have negative 2 and 3/4. 3 out of 4 quarters is 75 cents. So I have negative 2.75 and negative 2.25. Both of these are negative. Okay, so I'm in opposite land. So if they were both positive, this one would be bigger. But since we're in negative land, this one's bigger. It goes opposite. Opposite, opposite. Okay, the last one, well, 3/5. Let's figure out what that is. So I'm going to go to my calculator, and I'm going to do 3 divided by 5. Well, now I got to clear all that stuff. 3 divided by 5 is 0.6. Okay, so let's write that down. I have 0.6. Oh, it's negative. Negative 0.6 compared to negative 0.35. Well, if you notice, both of these are negative. So in positive world, let's make them both have the same numbers behind the decimal. So we have 60 and 35. In positive world, 60 is bigger than 35. So in negative world, it must be opposite. Okay, because negative 35 hundredths is closer to 0. It's not as far behind it. So that is comparing rational numbers. We're not just comparing positive numbers anymore. We're comparing negatives, and everything is backwards with negatives because you're on the other side of 0. Now, that is all we did in class. So what I want to focus you on Canvas is a Desmos calculator if you need it, okay, and then modules. When you go to modules, you're going to find, the outcomes, the standards, all of those things. Here's today's lesson. Okay, your homework is in Solvus Realize. But before we talk about your homework in Solvus Realize, I want to talk about these videos and resources for help. If you click on the resources, it shows you extra videos by Khan Academy, which is amazing, that can help you learn this topic. So this top one is all about integers on the number line, comparing and ordering integers and opposites. And this second video is comparing rational numbers. So if you're struggling and you didn't understand what I just taught, maybe I didn't do a good job teaching it and it didn't make sense to you, so come over here and watch this. Now your assignment is 8 questions in Solvus Realize. Remember, to get to Solvus, we go to our waffle, we go to Easy Bridge, and then we go to Solvus Realize. Okay guys, that's all for me. Bye.